We're going to find the volume of the solid of revolution obtained by the graphs of the parabola y equal to 4 times x minus 2 squared, the parabola y equal to x squared minus 4x plus 7 about the y-axis. First thing we have to do is graph both of these parabolas. So I'm going to divide the screen in two. The first parabola is 4 times x minus 2 squared. We can write this as 4 times x squared minus 4x plus 4, or 4x squared minus 16x plus 16. The vertex of this parabola is found from this form. It is the point 2, 0. When x equals 2, y is 0, and we cannot get any point lower than that. We can't find any y coordinate lower than that. The y-intercept is obtained by plugging in 0 for x, so it is a point 0, 16. For the second parabola, y equal to x squared minus 4x plus 7, we put it in the standard form ax squared plus bx plus c. So a is 1, b is minus 4, and c is equal to 7. The x coordinate of the vertex is minus b over 2a. In our case, it's minus a minus 4 divided by 2 times 1. That's 4 divided by 2, which is 2. To find the y-coordinate, we plug in 2 for x, so y will be 4 minus 8 plus 7, which is 3. So the vertex is the point 2, 3, and the y-intercept, plugging in 0 for x, we get 0, 7. Both parabolas open up because coefficients of x squared are positive. So now we can graph our region. The first parabola, we just need some points that we found. So this is point 0, 16. Let's call this point right here 0, 7. This is the point 2, 0. And this is the point 2 and 3. So let's graph the first parabola. The first parabola has the vertex 2, 0 and the y-intercept up here at 0, 16. So this is the right part, the left part of it, and this is the right part. The second parabola does that. And you can see the region is right there. That's the region that will be rotating about the y-axis. We're going to need to find the points of intersections of the two parabolas. Right here we just need their x coordinates, so we take 4x squared minus 16x plus 16, set it equal to x squared minus 4x plus 7. Let's move everything to the left. 4x squared minus x squared, 3x squared, minus 16x plus 4x is minus 12x. 16 minus 7 is 9. And now divide everything by 3. So we have x squared minus 4x plus 3 equal to 0. And this factors into x minus 1 times x minus 3 equals 0. So the x coordinates of the points of intersection are 1 and 3. So we can mark those. This is 1 and that is 3. It's probably better just to redraw this region, just the part that we need right over here. I'm going to go ahead and do that so we can determine the formula for the volume easier. Here is the first part right there. That's the first parabola. It goes like this, and the second parabola starts here and goes to here and here. This is 1 and that is 3. Let's mark these parabolas. This one is y equal to x squared minus 4x plus 7. And this parabola over here is y equal to 4x squared minus 16x plus 16. We'll be using the shell method because the washer method is much harder. I'm going to pick arbitrary x between 1 and 3. So let's pick this x here, and keep track of this vertical slice of the area of our region as it rotates about the y-axis 180 degrees into the rotation. It ends up here, and then a full 360-degree rotation yields this cylindrical shell. So the problem comes down to finding the surface area of the cylindrical shell as a function of x and integrating from 1 to 3. So recall, when we have a cylindrical shell, that is shell, not the top and the bottom, with radius r and height h, to find its surface area, we cut along the height and unfold it. And when we do that, we end up with a rectangle. The width of the rectangle is the height of the cylindrical shell, and then the length is what used to be the circumference, and that's 2 pi r. And so then the surface area is 2 pi rh. We want to express r and h as functions of x. You can see from this picture the center of the shell is right here, so the radius is to here, that's x, and then the height is this part, and it's just the difference of the y coordinates of the top parabola minus the bottom parabola. So setting up our integral for the volume, it's going to be 2 pi times the integral from 1 to 3. The radius is x, and the height is the big parabola, x squared minus 4x plus 7 minus the parabola below it. We'll put that in parentheses. That's 4x squared minus 16x plus 16. Make sure you put it in parentheses, because if you don't, you're not going to get the signs right. So now it's a matter of evaluating this integral, and this is equal to 2 pi integral 1 to 3 x times negative 3x squared plus 12x minus 9. So let's go ahead and send in the x. This is equal to 2 pi integral from 1 to 3, and then minus 3x cubed plus 12x squared minus 9x dx. Well, this is a very easy integral to evaluate. It's just a matter of plugging in the number. So this is 2 pi times, the integral is going to be minus 3 over 4 x to the 4th plus 12 over 3 is 4, so 4x cubed minus 9/2 x squared. All this is evaluated from 1 to 3. So let's go ahead and plug in these values. First, let's plug in 3. 3 to the 4th is 81 times negative 3, that's minus 243 over 4. Then 27 times 4 plus 108, and then minus 81 over 2. That's plugging in 3. Let's plug in 1. Plugging in 1, we get minus 3 over 4 plus 4 minus 9 divided by 2. So let's go ahead and compute that. Minus 243 over 4 minus a minus 3 over 4, we get 2 pi times minus 240 divided by 4. 108 minus 4 is 104, and then minus 81 over 2 minus a minus 9 over 2 is going to be minus 72 divided by 2. So this is 2 pi times 240 over 4, that's negative 60 plus 104 plus minus 36, and that's minus 96 plus 104, that's 8 times 2 pi. The final answer is 16 pi.